this video, we're going to talk about pointers. So what is a pointer? Before we can understand pointers, we need to understand a little bit about computer memory. Think of computer memory like a bunch of empty blocks. When we need to store something in memory, we say, give me one of those blocks and let me put something in there. When we create a variable, that variable is stored at a memory address or a specific location or block in our system. Let's take a look. I'm going to be using GoLang for this. I've already created my project. It's called Pointers in Go. I've created my main.go file, and I have my package main and my func main. This is going to be an executable file, and we're going to be printing out some information down here in the terminal. So I'm going to go ahead and close this. To get started, I'm just going to create a variable. We'll call it A. We're going to use the short assignment operator, and we'll set it to 5. And let's just print out our A variable. So we'll use fmt println, and we'll pass it the variable A. You can see that my IDE imported the fmt package for me, so I'm good to go. Let's go ahead and run this and make sure everything's working. Go run main.go, and we printed out our variable A. So as of right now, we have this variable A. When we ran that program, what happened behind the scenes was our program said, hey, we have one variable. We used the short assignment operator, so our computer identified this variable as an integer, and it told our system, hey, I have this integer. I need you to save this for me somewhere. That somewhere is in memory. So you're probably asking yourself, okay, it saves this variable for me in memory somewhere, but where? So if we wanted to see where the variable A is stored in memory, we can use the ampersand sign. So if I was to come up here and just append the ampersand or the and symbol right here, this is like saying, show me where the variable A is stored. The ampersand points to the location, not the data itself. So if we were to run this again, we're not going to see 5. We're going to see the location or the memory address of where the A variable is stored. Let's try this out. Let's run this again. This time, we're returning the location right here. This is the location or the memory address on our system where this variable is stored. Think of it like a house address. This is where the house lives. It's not what's inside the house. It's just the location of the house. If we want to see what's inside, we have to remove the ampersand, and we can run it again, and we can see that inside our location, we have this variable 5. Now that we can see the location of where our computer stored the A variable, let's create a B variable and set that equal to A. So I'm just going to jump down here, and we'll just say B. We'll use the short assignment operator, and we'll set that equal to A. And let's print that out as well. I want to continue to print out the location of A. So now we're creating our variable. We're saying print out our variable A, and then we're saying print out the location of where this variable A is stored in memory. Then we say create a new variable, set that variable equal to A, and then print out that variable, that new variable that we just created. And then just for fun, let's go ahead and print out the location. Since we're printing out the location of our A variable, let's print out the location of our B variable as well. So fmt println, we'll use the ampersand and B. So we're saying print out our B variable and also print out the location or the home address of where this B variable lives. Let's run this again. So we printed out our A variable, which is 5. We printed out the memory address right here of our A variable. Then we printed out our B variable, and now this is the memory address of our B variable. Now it looks very, very similar to our A variable, but if you'll notice, the last 4 digits of the memory address for our A variable are 2008, but the last 4 digits of our B variable address are 2018. So we can see that these are 2 separate locations for the A and the B variable. They're different. Although they both contain the same value, they're occupying 2 separate locations in memory. The variable B is essentially a copy of A. If we were building a really big program and we had a lot of variables, we would be consuming a lot of space in memory. Since we know where the variable a is located in memory, we can do some cool stuff. Let's set the b variable equal to the variable a location, or its memory address. So if we come up here and we say b, we'll use the short assignment operator, and we know the ampersand says give me the address of this variable. So if we append the ampersand, now we're saying set b equal to the memory address. Don't set it to the value. We don't want the number 5. We want to set b equal to the address of a. So I'm going to get rid of this for right now, and let's run our program one more time. Now that b is equal to the location of a, let's see what it prints out this time. Now we can see our first println of a is 5. Our second println is the location of a, which is this right here. And then we're saying print our variable b. This time, if you'll notice, our a location and our variable b are exactly the same. Now instead of having a copy of a stored in a different place, we're saying point b to the address or the location of wherever a is. But now that we're pointing to the address of a, we don't really want to know the memory address. We want whatever the underlying value, what is stored in a. So we know the ampersand right here, the and symbol, points to a location. If we want to point to the value at that location, so what's inside of the location, not the address, we want the underlying value, we can append the asterisk. So we can say asterisk b, and this says grab me the value of whatever b is pointing at. So since b is pointing at the address of a, it's saying get me the value inside of that address. I want to know what's inside of that. So let's run this again, and this time we're anticipating 5, a memory address, and then 5 again. So let's see. So we've created our variable a, we created a variable b, and we said point b to the location or the memory address of a, and then we said print out whatever's inside of that location. So we're able to point at a and see what's inside of a. Since b is pointing at a, we can also use the asterisk with the b variable to change the value stored at an underlying memory address. Both b and a now have the same memory address or location. Since a has its own location and b is pointing at a, they're at the same spot. They're looking at the same space on our computer. So if we define asterisk b and set it equal to something, let's just say 10, we can change the value stored at that memory address. So hypothetically, the value of a should change as well. Let's give this a try. So we're going to say asterisk b, we're going to set it equal to 10. So we know when we created our b variable right here, we said we're pointing it at the location of wherever a is. So wherever a is, this is what we want in our b variable. But then with the asterisk, we're saying go to that location wherever b is pointing, and we want to look at the underlying data. Change that underlying data, set it equal to 10. Let's print this out. Let's do fmt println, and let's print b, and then let's also print a. So fmt println, and we're going to print a as well. And I'm just going to change this back to how it was originally. So we should now see for this println right here, we're expecting to see this println to be the memory address of a as well. Let's go ahead and run our program again. I'm going to slide this up a little bit because we printed out 5 values to the screen. So our first println, we have a, and a is set to 5. Our second println, we said, give me the address of a. What is the memory address of a? And that's this, we'll look at the last 4, 2008. And then we say, create this variable of b and point it to the memory address of a. Wherever a is stored in memory, we want to point b to that. And then we said, println again. And that's our second memory address value right here, which is exactly the same as our first one because we pointed b to the memory address of a. Then we came down and we said, we use the asterisk in b and we said, wherever B is pointing at, go find that address. We want to change the underlying data that's inside of that address. And we said, set that data equal to 10. Then we printed out B again, which is exactly the same as the previous B. It's just the memory address again. And then we said, print out the value of A. Now, when we printed out A the first time, it was equal to 5. And now we're printing out A again, except this time it's equal to 10. Since B is pointing to the address of A, by using the asterisk, we're saying change the value inside of this location, and we set it to 10. Since B and A are both pointing to the same memory location, we're able to use B to change the value of A. If we wanted to, we could put the asterisk in front of B and say print out the value of the underlying address stored at the location of wherever B is pointing at. So if we run this again, we should see 5, memory address, 10, 10. Let's give it a whirl. And just like we thought, 5, the same exact memory address for A and B, and then the underlying value of wherever B is pointing at, which is A, which has the value of 10, and then the value of A, which is also 10. This was a super basic example of how pointers work in Go. I wanted to break things down to the bare bones and show you guys what's happening behind the scenes. I think this is a good stopping point. Pointers are an advanced topic for a getting started tutorial, but hopefully after watching this video, you'll have a general understanding of what pointers are and how they work. If you're coming from another language, I think the best way to sum up pointers is you use pointers when you need to store or share state. So if multiple parts of your application need to be aware of or update the same thing, you would use a pointer. Hopefully you learned something in this video. If you did, help me out and click the like button. I'll be posting more tutorials on Go, so don't forget to subscribe and click the bell icon so you get notifications, and I'll see you in the next video.